Dear student, dear students, welcome to EPG Pathshala. In this module, Introduction to Random Variables and its Properties, I will discuss what is variable, what is random variable, types of random variables and its property. Generally, we consider variable as a thing that is used to measure a particular quantity. For example, we use a variable to measure heights of different students, weights of different students, and so on. Here, we try to consider that how a variable is used in probability theory. Basically, in probability theory, we consider a variable that is a function or mapping from events to real line. So, we here try to develop this thing in very easy manner. Hope you will enjoy this module. Let's get started. The basic objective of this module is to first define the random variable, then we will define the behavior and properties related to the random variable. Some introduction to probability distribution is given so that one can understand the relationship between random variable and distribution functions. Some properties like mathematical expectation by using related mathematical formulation and examples are also discussed. Mostly, an experimenter has an interest in those outcomes that occurs in a random experiment. Then the next question that arises, how to compute them, that is computation of these outcomes, probability definition and probability concept are used to find these outcomes and the numerical measure in terms of probability. If an experimenter is only interested in numbers of outcomes in a random experiment and computation of numbers of outcomes instead of type of outcomes, then both random variable and probability distribution concept are used. Suppose n dice are thrown in a random manner. The experimenter wants to know about the sum of coming points on the faces of the dice. These types of problems are solved by probability concept and definition, which have been already discussed previously in the modules related with probability. Suppose n coins have been tossed randomly. The experimenter is interested in to find out the number of tails obtained while tossing a coin when such type of events occur. Experimenter has an interest in association of random numbers to these upcoming outcomes. The association of random numbers to each outcome is known as random process, and random association is known as random variable. Distribution of random variables and its properties is defined as probability distribution. Probability distribution will be used to find the probability and other properties of random variables like mean, median, variance, movement generating function, etc. Sometimes random variables are used several times to make these random variables useful for practical purposes. Then mathematical expectation is used. Suppose a businessman wants to know his average profit on a commodity. A cancer specialist doctor wants to know his average number of patients diagnosed with successful treatment. Mathematical expectations are used to solve these types of problems. Random variable, probability distribution, and mathematical expectations are the most important terms that are used in the probability theory. These terms are also used in programming language to find out the characteristics of the data. In programming languages, these types of properties are defined as summary of the data. In summary, many properties of the data are included like variance, mean, mode, median, quantile, quartiles, minimum value and maximum value. Now we will discuss with definition of random variable. One thing will strike in your mind when you listen the word random variable. One may assume that the random variable is a variable. That is not absolutely correct. One can have controversy with the name. Random variable is a function instead of just a variable. Function is a relationship between two well-defined sets. One set is known as domain and second one is range. Similarly, random variable is relationship between two sets. One is set of possible outcome that is sample space, and second one is subset of real number. Set of possible outcomes is known as domain, and subset of real number is known as range. Random variable is a function whose domain is a set of possible outcomes and range is a subset of set of real number. Random variable is normally denoted by capital letters like capital A, W, capital S, capital Z, U and P, etc. And outcomes of a random variable is denoted by small letters of alphabetics like A, S, C, X, Y, Z, etc. So the mathematical expression, say capital X be a random number connected with the outcome of a random experiment capital E, and S be a sample space of the random experiment capital E, and Z represents the each outcome of the experiment capital E that comes from a sample space capital S, and X into XZ represents the real number to each outcome Z is known as random variable. A random variable XZ is a function whose domain is a sample space capital S and range is a subset of the real number, that is minus infinite to infinite. For example, tossing a coin 3 times at random is a random experiment capital E. Let us define random variable as a function for counting the number of heads, that is 0, 1, 2, 3, or to count the number of tails 0, 1, 2, 3, or to count the number of head or oblique tail appears at first place in a random experiment capital E. Here we define the random variable as a function to count the number of heads, it can be 0, 1, 2 and 3, that occurs in an experiment with a sample space given here as HHH, HHT, HTT, HTH, THH, TTH, THT and TTT. So each outcome of the sample space is represented by small z. Random variable xz is equal to h if it takes value 0, 1, h is equal to 1 if it take value 3, h is equal to 2 if it take value 3, h is equal to 3 if it take value 1. So when number of head is equal to 0, random variable xz is equal to 1. When number of heads is equal to 1, random variable xz is equal to 3, because we have 3 possibilities where head appears one time. And when number of head is equal to 2, random variable xz is equal to 3. It means when from the sample space as we have head appears at 2 times, so the total possible value is x is equal to 3. So when number of head is equal to 3, the random variable take value 1. So we have some remarks here. A linear function of the random variable is also a random variable. Suppose x and y are 2 random variables. Following 3 linear functions of 2, the random variables are also random variables. For example, let us suppose we have x and y are random variables. So linear form, that is 2x plus 5y, xy and x plus y are also random variables. That means it satisfies the properties of random variable. If x is a random variable, then 1 upon x and mod of x, maximum of x1 and x2 and minimum of x1 and x2 are also random variables. So it means it preserves the properties of random variable. If you take proportion, that is 1 upon x, mod of x and maximum value or minimum value. A continuous and increasing function of random variables are also random variables. So now we will discuss different types of random variables. It is very important to understand these types in depth, because we would use these types again and again in our coming modules. So it is essential that you must have a clear concept about this topic. Suppose the number of students in a class is 50. That shows whole number and height of students that may lie in some interval, because it may be 4.5 or 6.1 and or 5.1 in inches. According to example, a random variable may be associated with either a finite countable number as well as infinite countable, that is discrete value, or in finite uncountable interval or continuous values. Random variable is classified as of 2 types. First is discrete and second one is continuous values of variable. So we would like to start with first with the discrete random variable. Discrete data means integer data. That means it does not include decimal values and considered only whole values. Discrete values can be positive or negative, for example plus minus 1, plus minus 2 and so on up to infinite. Discrete random variable is a random variable which assumes only finite and countable values. So there are few list of examples of discrete random variables. Suppose first example is number of phone calls in a day. So it is a discrete integer term. So we consider it in a discrete random variable. Number of road accident in a day. Similarly, number of claims in a day, number of job seekers for a data scientist job, number of grammatical errors in a text, because it does not have any fraction terms involved in the outcomes. So we take discrete random variables. So number of customers in a showroom, number of defective products in a manufacturing company, number of product produced by a manufacturing company, and so on. So now we will discuss what is continuous random variable. Continuous data means real number that include decimal values. Continuous values are like as 2.3, 5.6, 9.8 and 8.7. And any value that lies between the interval 1,3, 7,9, etc. These intervals may contain infinite values because between interval limits. Continuous random variable is a random variable which can take any value in a given interval. So there are few list of some examples of continuous random variable. These are closing price of share market, temperature of metropolitan cities or on a particular day, distance traveled by a truck driver, time taken by a bus service in traveling from Jaipur to Bathinda. So now we will discuss an important thing, that is probability distribution function. Frequency distribution is used to arrange repetitive data in an appropriate manner. For example, class reported each day for 1 week is given as 0, 1, 2, 1, 3, 4, 1, 0, 2, 5, 4, 3, 7, 6, 6, 5, 2, 4. This data set have repetition of some value. In the data set 0 occurred 2 times, it means frequency of 0 is 2. We already discussed the concept in our basic course of descriptive statistics, so one can refer that one if someone is difficult in finding out the frequencies. Frequency denotes the number of data value occur. Another representation of the data set is called frequency distribution. So in the first row we have number of claims reported each day. So we have either we have no claims, either we have one claim, so on. We have maximum here 7 claims in a day, and frequencies are given in the second row. That is, we have if we have no claims, then it occurs 2 times. So if we have one claim, that it occurs 3 times, and so on. This frequency distribution shows the distribution between frequency shared in the data set values. Probability distribution shows the distribution between probabilities and data values like frequency distribution. For example, tossing a coin 2 times and a random variable x denotes the number of heads. The probability distribution of x is given as in the first row we have possible outcomes, that is head head, head tail, tail head and tail tail, and corresponding to events we have x as a random variable that takes value 2, 1, 1, 0, and probability of x is given here as 1 by 4, 1 by 4, 1 by 4 and 1 by 4. So it means the probability of x is equal to 0 is 1 by 4, and probability of x is equal to 1, that means we have one head occurs, so we have to club the two probabilities by using the additive property of probability, that is 1 by 4 plus 1 by 4. So the answer is coming out to be half. Similarly, to find out probability of x is equal to, the answer is coming out to be 1 by 4. So the probability distribution is a function which distributes the probabilities of a random variable to each outcome of random variable. So here we will discuss the mathematical representation of random variable. Suppose random variable is denoted by capital S and its outcome is denoted by small z. Then the probability distribution function is given as probability of x is less than equal to x, which is equal to probability of small z, given that probability of xz is less than equal to x, where x lies between minus infinite to infinite. This is also called distribution function and cumulative distribution function. Now we will discuss here the probability mass function. What is probability mass function here, and what type of properties that are followed by this function. If x is a random variable and z are the outcomes, then the function pxz is given as probability of zi if z is equal to zi for all I vary from 1 to so on, and it takes value 0 otherwise. So function pxz is called the probability mass function of a random variable capital X. A function will be called probability mass function if it follows following condition. First is probability of zi should be greater than equal to 0 for all i's, and summation over probability of zi where summation is over I where I vary from 1 to infinite, it should be equal to 1. For example, let us suppose we have a we roll a dice which has 6 possible outcomes, and sample space is given here as 1, 2, 3, 4, 5, 6, and let x be the random variable, and it is defined in such a manner that it takes value 1 if even number phase of dice occur, and it takes value 0 otherwise. As we know that we have 3 even faces and 3 odd faces, so probability of x is equal to 1, and which is by using the basic concept of probability that it is equal to favorable outcome divided by total outcomes. So it is coming out to be half here, and probability of x is equal to 0, its also value is half. One can see that this function is probability mass function at it satisfies the condition of probability mass function. First condition is that probability should be greater than equal to 0, and second is if you take summation over all the possibilities, then the sum is coming up to be 1. So here we can see that when the probability of x is equal to 1, the value is coming out to be half, and the probability of x is equal to 0, the value is coming out to be half. When you sum these two values, then the outcome is coming out to be 1. So here we show a graphical representation of the probability mass function of the random variable, and it is given in here as in the figure 1. We have on the x-axis we have x values, and correspondingly we have probability values that is shown in the y-axis. As you can see that different values of x have different probabilities. So when you sum all the probabilities of x values, then the sum is coming out to be 1. So graphical representation of distribution function of the discrete random variable is represented here in figure 2. So on the left hand side we have probability of x1 is less than equal to x1. So we are taking cumulative probability here. That means that if you have values x equal to 0, 1, 2, 3 and so on, so after finding out the probability of x equal to 0, when you will find out the probability of x is less than equal to 1, then we already club up the value probability of x equal to 0 in probability of x is less than equal to 1. So after clubbing all the probabilities and taking sum, you will get this type of graph, and from this graph you can see that when you have your x value approaches to infinite, that means we have infinite countable infinite number of events. So when you take probabilities of all the events and taking limit, it means the probability value is coming out to be close to 1. Two dices are rolled. In this sample we discuss a very simple thing, that is when we have two dices and we roll two dices here, and x be random variable which is sum of the upturned faces is even. So we first construct probability distribution function and find the distribution function of x for 1. That is, we are interested in to find out the value of f of 1, where fx denotes the CDF. That means it is equal to probability of x is less than equal to x, small x. So the two dices are rolled in a random experiment, and sample space is given here as we have 36 possibilities. So we have first 6 possibilities as 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, and so on. Other possibilities are 2, 1, 2, 2, 2, 3, and so on 2, 6, and 3, 1, 3, 2, so on 3, 6, and similarly so on. So random variable x is given as x takes value 1 if sum is even, and it takes value 0 when sum is odd. So outcome of random variables are when x is equal to 1, we have 18 possibilities, and x is equal to 0, we have 18 possibilities, because x is equal to 1 means when sum is even, and x is equal to 0 means when sum is odd. So as we know that we have total 36 possibilities, so half is even and half is for odd. So probability mass function of the random variable is given as here as probability of x is equal to 0 is equal to 18 by 36, and probability of x is equal to 1 is also 18 by 36. As we see that this function satisfies the condition of distribution function, that means all the probabilities values are greater than equal to 0, and when you take the summation of all the probabilities, that value is coming out to be 1. This function of distribution function is given here as probability mass function is given here as x is equal to 0 and 1, then the probabilities are half and half, and the distribution function is given here as f of 1 when x is less than equal to 1. That means we are clubbing all the probabilities of 0 as well as 1, so the answer is coming out to be 1. Now we have another question. A random variable x has a following distribution function. So it takes value 0 when z is less than 0, and fz is equal to 18 by 36 when z lies between 0 and 1, and when z is greater than equal to 1, then it takes value 1. So here we have possible values of x are given here as 0, 1, 2, 3, 4, 5, 6, and p of z is given as a, 2a, 2a, 2a square, a square, a square plus a, 3a square. So here a is a constant, and we are interested in to find out the value of a. So first, and we also have to draw chart of probability distribution and discrete distribution function. Now how to solve this type of problem? So first we have to consider the two conditions that a probability function must satisfy. First is that all the probability value should be greater than equal to 0, and another one is that when you sum up all the probabilities, then the sum is coming up to be 1. So using this property, you have to add all the possible probabilities and equate it equal to 1, and the value is coming out to be, by using the formula, the value is coming out to be a is equal to -1 and a is equal to 1 by 7. So how you will derive this value? First you have to write it down, a plus 2a and 2a square and so on. Now you have to add all the terms that has same power of a. So after factorizing, we will get the value of a is equal to -1 and a is equal to 1 by 7. As we also know that the probability value should be positive, so we can't take a is equal to -1, we have to consider the value of a is equal to 1 by 7. So after taking a is equal to 1 by 7, now you can find out the probability distribution function, which is given here as we have possible values of x is given here as 0, 1, 2, 3, 4, 5, 6, and probability of x is, after putting the value of a, we can find out the value of probability of x is equal to 0 is 0.14, and probability of x is equal to 1 is 0.28, probability of x is equal to 2 is 0.28, and probability of x equal to 3 is 0.04, and probability of x equal to 0.04, and so on. Probability of x is equal to, say, we have the value 0.06. The probability function for x is given here as we know that how to find out the distribution function, we have to club the probabilities. So as we probability of x is x equal to 0 is 0.14, then when you club the probability of x is equal to 0 in probability of x equal to 1, the value is coming out to 0.42857, and so on. You can find out the probability of x is equal to so similarly you can find out the distribution function for x equal to 2, 3 and so on by clubbing all the previous probabilities that can be shown here in table number 4. So after finding out the values of these probability, now we are interested in to plot these probabilities in the figure. So figure 3 represent these probabilities values, and from this figure you can see that first value is shown here in the table, in the figure. and it is shown as 0.14285 and so on. We have the total probability value here and it is coming out to be 1. So the bar chart of probability function of x variable is given here, and it is just the same thing that we are representing here in the previous graph as a cumulative sum. Now we are representing here as an individual probabilities values. Now coming out for the continuous random variable probability distribution function, and it is called probability density function. If x be a random variable, continuous random variable, and z outcomes come from a b interval, area under this interval will be called as probability density function. Probability density function of PDF of x will be given as f subscript x and z, and if x lies between a and b and it is equal to integration of ab f z dz, a function will be PDF in interval if it takes value minus infinite to infinite. Then function must satisfy the following condition. The first condition is probability of f of z is greater than or equal to 0, and if you take the integration from the range minus infinite to infinite, f of z dz is coming up to be 1, and p of e is equal to integration with interval is over e f z dz, where e is an event of the random experiment. So if x is a continuous random variable with PDF f of z, the function is given as probability of x is less than or equal to 1, and it is represented by capital Fx notation, and which is equal to minus infinite to x f z dz, and it lies between minus infinite to infinite. The function f of x is called distribution function or continuous distribution function. Now we have a question here. So a continuous random variable x has the PDF which is equal to m e minus 3z, where z is greater than or equal to 0. That means we have positive real line. So find the value of m, and probability of x is less than or equal to 8. So we have to use the property, that is, if you take integration over the interval of distribution function, then the value is coming up to 1. So we are interested to find out the value of m, which is unknown. So using the this property, we can, after solving this, we can find out the value of n. So here, after opening the integration part and after putting the value of the range in the integrand, we will get the value of m is equal to 3. Now to find out the value of probability of x is less than or equal to 8. So for that we have to use the definition of distribution function, that is, we here as range defined as 0 to infinite. Now we have the upper limit that is equal to 8. So after solving the integration and putting the limits, and we will get the expression as 1 minus e power minus 24, and after solving the value of e minus 24, that is equal to 3.775135 e minus 11. So the approximate value of x is less than or equal to 8 is coming up to be 1. Now in this section we will discuss the mathematical expectation. We already discussed about the PDF for the continuous distribution, continuous variable, and PMF of discrete variable. Now we have to consider other properties of these variables, and it is termed as mathematical properties. Once PDF for the random variables is determined, often one wants to compute expected value or average value of random variables. Expected value for a discrete random variable is a weighted average, where weights is the probability to the associated random variable values. Mathematical expression for the expected values of discrete random variable x with probability mass function is given here as expectation of x, and which is equal to summation over z which is equal to z into f of z. Mathematical expression for the expected value of continuous random variable x with PD of f of z, which is equal to expectation of x, and integration is over the interval, that is minus infinite to infinite z f z dz. Note, expected value for the random variable exists of right hand side of mathematical expression is convergence, that is finite value of the variable exists. Now the some properties of mathematical expectation. Expected value of function of random variable is same as the expected value of the random variable. Mathematical expression for the expected value of function of discrete random variable g of x is given here as expectation of gx, which is equal to summation over z gz fz. Mathematical expression for the expected value of functions of continuous random variable g of x is given here as expectation of gx is equal to minus infinite to infinite gz fz dz. Second is, if the expectation of two random variables x and y exist, expectation of addition of two random variables is equal to addition of expectation of respective two random variables. So the mathematical expression is given here as expectation of x plus y is equal to expectation of x plus expectation of y. This property also holds for function of random variables. If the expectation of two random variables x and y exist, expectation of multiplication of two random variables is equal to multiplication of expectation of respective two random variables. So mathematical expression is given here as, so the property of this hold for function of random variables, that is expectation of xy is equal to expectation of x and expectation of y. Fourth property is expectation of any constant is equal to constant. Let us suppose c is any constant value, then mathematical expression is given here as expectation of c which is equal to c. Expectation of linear combination of random variable or function of random variable is given as expectation of ax plus c, which is equal to a of expectation of a of expectation plus c, where a and c are two constant and x is a random variable. Now we will discuss some properties or how movements can be found out from this properties of random variable or mathematical properties. Movements are used to find basic calculation of mathematical statistics and probability distributions like mean, variance, skewness and kurtosis. Mean is first central movement about mean, variance is second center movement about mean, skewness is ratio of square of third center movement to cube of second center movement about mean, and kurtosis ratio of fourth center movement to square of second center movement about mean. So mathematical expression for the movements are given here as mathematical expression of movement of about mean is given here as the rth center movement about mean of a random variable x is given as mu r, which is summation over r xi minus x bar whole power r divided by capital N, where I and r vary from 1 to n, where summation over fi is equal to capital N. Now the rth movement about any point A, and it is noted as summation over r xi minus a whole power r divided by n, where I and r vary from 1 to n. When r is equal to 1, 2, 3 and 4, the movements are denoted as mu1 dash, which is equal to mean, variance of r which is equal to mu2 and which is equal to mu2 dash minus mu1 dash, and mu3 is equal to mu3 dash minus mu2 dash mu1 dash plus mu1 dash cube. Similarly for mu4, which is equal to mu4 dash minus 4 times mu3 dash into mu1 dash plus 6 times mu2 dash mu1 dash minus 3 times mu1 dash 4. Now measures of skewness and kurtosis. We already discussed the measure of skewness kurtosis, but how we can correlate the movements with the center order movements. So b1 is equal to mu3 square divided by mu2 power cube. So measure of kurtosis beta is equal to mu4 divided by mu2 power 2. So here we have an example here, that x be a random variable with following PDF. Fx is equal to 3x square, where x lies between 0 and 1. We are interested to find out the expectations and variance. Since mathematical expression for expectation of continuous random variable is given here as expectation of x is equal to minus infinite to infinite x fx dx. So outcome of random variable x is noted as x that lies between 0 and 1. So expectation of x which is coming out to 0 to 1 x fx dx, 0 to 1 x 3x square dx. So expectation of x after solving the integration and putting the limits, we will get the value as 3 by 4. So mathematical expression for variance of random variable is given as variance of x which is coming out to expectation of x square minus expectation of x whole square, expectation of x square which is equal to 0 to 1 x square fx dx, and expectation of x square which is equal to 0 to 1 x square 3x square dx. Hence expectation of x is 0.75 and variance is 0.4125. So after putting the limits on the integration, we will get expectation of x square is equal to 3 by 5 and variance of x is equal to 0.4125. Hence expectation of x is 0.75 and variance of x is 0.4125. In the end, I would like to conclude this module, that is introduction to variables and its property. In this module we discuss what is random variable, what is continuous random variable, what is discrete random variable. After discussing these two variables, we also discuss the PDF and PMF, which is probability density function and probability mass function. We also discuss moments and other things like variance, skewness, kurtosis, etc. Hope you enjoy this module. Thank you.